We've looked at unions so far. Another way to combine sets is via what we call the intersection of two sets. We'll also take a look at set difference, which is pretty much the last operation that enables us to do anything we want to the sets we're working with. So imagine that instead of taking all the elements from one set and the elements from the other set and combining them into one brand new set, suppose we only want to take the elements the two sets have in common. So only take the elements that basically are in the intersection of the two sets when we look at the Venn diagram. So for example, suppose we have two folders containing information about clients of two banking branches. We want to know what clients are at both branches. So what this might look like is we have maybe some folder that contains all the client information, and we'll just call this B1 for branch 1. And then this has a series of customers that shop there, customer 1, customer 2, and we'll just say customer 3 to keep this light and simple. Branch 2 is going to have a series of clients itself, or that's going to have files related to those clients. So maybe it has client 4, client 3, and client 2. So the question is, we want to take these two sets and we want to combine them in such a way where we only find the clients that are in common between the two sets. So if I look at these two folders, then the only files that are in both set B1 and set B2 is customer 2's file. So what I would like to report is a brand new folder, which maybe I'll just call this set A, and set A is going to contain only the element C2. So it's only going to contain the file that is in both of those folders. So you can probably think of a lot of applications where we only want to grab files that are in two distinct folders. More formally, this operation is known as the intersection of two sets. If we call those sets A and B, then using this notation, A with an upside down U, B, means A intersect B. Or you can say A intersection B, or the intersection of A and B. There are many ways that you can say that. But what that is in a nutshell, it's the set of all elements. It's a brand new set, contains only the elements that are both in X or in A and inside of B. So let's go ahead and define a couple of sample sets here. Let A consist of the elements 1, 2, 3, 4, 5, and let B consist of the elements 2, 4, 6, 8. So if I represent this in a Venn diagram, again, our universe is kind of unknown here. We don't know what we're talking about as the universe. It could be the set of all real numbers or just the set of all integers. It could be a lot of different things. But inside of here, I have set A, and inside of set A, I know I have 1, 2, 3, 4, 5. But before I do that, I'm going to draw set B because I see that they do have stuff in common. So here's set B. And inside of set B, we'll go ahead and start with that. It has 2, 4, 6, 8. But A also has 2 and 4, so we're going to list the elements 2 and 4 as being in common between the two sets. This set B also has the elements 6 and 8. A has the elements 1, 3, and 5. Those are elements that are distinct to A that are not also inside of B. So if I want to form this brand new set C, and it's going to be the intersection of the two sets, all I need to do is look for what's in common. Well, what's in common is inside of this region right here. This is what's in common between the two sets, and those elements are 2 and 4. Therefore, this brand new set is only going to receive the elements 2, 4. We could also do this with the real number line example. If I have a real number line and I define A to be the set of all numbers where X is bigger than 7, and B is the set of all numbers where X is less than 7, well, I can already see that they have nothing in common. If 7 is here, then A consists of the numbers that are bigger than that. So A consists of all of these numbers over to the right. B, on the other hand, consists of only the numbers that are less than 7, and we see that there's nothing in common between the pink shading and the blue shading. The open circle represents that that number is in neither set. So if I form the intersection of these two, it's going to have nothing in it. Therefore, we have a name for that, and the name for that is the empty set. Now, that's the intersection. A lot of times we want to find the elements that are in one set but not in the other. For instance, if our folders are the banking clients between two branches, we may only want to know the clients at one branch that do not do business at the other branch. So for instance, if I draw this to be branch 1, that's a folder and it contains files pertaining to customer 1, customer 2, and customer 3. And let's say that bank 2 consists of customer 2, customer 4, and customer 5. Then if I want to know the difference, which we'll write right now as really the difference, the minus, the subtraction between them, B1 minus B2 will be all of the elements that are in here, but not in here. Okay, so let me look at all the elements that are in here. C1 is in here, and C1 is not in B2. Therefore, C1 belongs to our set difference. So C2 is in B1, but C2 is also in B2. Therefore, C2 is not an element that is in their difference. It's an element that is in, we only want to know how B1 is different than B2. So B1 is not different in the element C2 because C2 is also in folder B2. C3 is an element of B1. I don't see it over here in B2. Therefore, the set difference between B1 and B2 is going to be, which we'll just go ahead and call this new folder C that we're forming. It's only going to contain information on clients 1 and 3. Those are the clients that bank at branch 1 but do not bank at branch 2. Again, more formally we can define this. This is known as the set difference of two sets. And we have to be careful because when we reverse the order of these, it's just like subtraction. When you take the difference between two numbers, like 5 minus 7 versus 7 minus 5, you don't get the same number. When you union two sets, you're just combining all the elements, so it doesn't really matter what order you consider them in. And same thing with the intersection, that's what elements are in common, so it doesn't matter whether you do A intersection B or B intersection A. This one is a little bit more sensitive to that. So written as A minus B, which sometimes you'll see, this is just an alternative notation, as A slash B, it's the set of all elements that are inside of A and that are not inside of B. So if something is not inside of B, we could say that it is inside of B complement. It's inside of the set, it's inside of the universe, but it's not inside of B. So let's take a look at a couple of examples. Let's again define set A to be some numbers, 1, 2, 3, 4, 5. We'll define B to be 2, 4, 6. So if we again look at this as a Venn diagram, which is just a helpful representation here, and we look at set A, and that's going to be set A, and we look at set B, and when we draw this out, we're going to notice pretty quickly what the set difference is. So inside of B, we see that there's 2, 4, 6, but 2 and 4 are both elements inside of A, so only 6 is inside of B, but not a part of A. Then inside of here, I'll have the elements 2 and 4, since those elements are common to both sets. And let's look at it inside of A. Well, I have 1, 3, and 5. So if I look at A minus B, and let's say I form this new set called C, because that's really what we're doing, is we're forming a brand new set, A minus B. Well, that's going to be all of the elements that are inside of A, but that are not inside of B. Well, this is just a pretty quick check because I see that 1, 3, and 5 are elements that are inside of A, but that are not inside of B. 2 and 4 are elements that are common to both of those, and I want the set difference. I want to know how is A different than B. So this is just going to be the set containing elements 1, 3, and 5. Now, I could also form a new, I don't want to call it the same thing, but let's just look at B minus A. That's all of the elements by which B is different from A. Well, it's readily apparent here that if I look at all the elements that are B, that are not inside of A, that's just going to be the element 6. That's the only way in which B is different from A. Now, I'm not looking at the elements that are inside of A that they don't share in common, because I just want to see how is B different from A. I don't need to describe the fact that 1, 3, and 5 are not elements of B. And with these two operations now, as a kind of an intuitive example, let's say I have those branches, or I have branch 1 and I have branch 2. And what I want to do is basically, maybe I'm going to combine these two branches inside of one big database. And the problem that we often face is duplicates. So if branch 1 contains information on these 3 customers, and branch 2 contains information on these 3 customers, then if I were to combine these into one brand new database, I would not want a repeat of customer 2. So if I were to form this brand new database, or this brand new set of folders, and I called this set C, then what I may want to have is the union of these two sets, which we already know will automatically remove the duplicates. But if you were working in a database structure and you simply put these two databases together, you might get the duplicate entry there. So just another way to think about this is what I want is to union all the elements that are inside of B and not in B1 and not inside of B2. Okay, so what will that look like? Well, that right there will contain all the elements that are in B1, which are C1 and C3. So that in its own right is a brand new set. And then I want to union that with all the elements that are in B2, but that are not in B1. Or rather, all the elements that are by which B2 is different than B1. So B2 minus B1 will be the set consisting of elements C4 and C5. And if I union these two together, what would I get? Well, if I union them together, then that just says combine all of the elements, and that would be the elements C1, C3, C4, and C5. So this is a way, if I wanted to, for some reason, treat C2 as a special case or add C2 to another database, then this would allow me to eliminate the element that is in common to both sets. One other way to do that would be to say that this is the union of B1 and B2 minus the intersection between B1 and B2. So just ways in which we can get creative with sets in order to do different things. And this is why I mentioned at the beginning of this video that these are the last two operations that we really need to construct any sort of set that we want.